This video is about angular speed and angular velocity. Angular speed is the rate at which an object is rotating and is represented by the Greek letter omega. Angles are represented by the Greek letter theta and change by the capital Greek letter delta. So angular speed, omega, is given by the change in angle divided by the time taken. One complete rotation is 360 degrees, or 2 pi radians. This Ferris wheel completes a revolution in 6 seconds, so has an angular speed of 2 pi divided by 6, giving pi over 3, or approximately 1 radian per second to one significant figure. There are other units you might come across for angular speed, like RPM, which stands for revolutions per minute. This gramophone is playing a record at 45 RPM. To convert this into radians per second, we find the total angle revolved, which is 45 revolutions of 2 pi radians, divided by 60 seconds in a minute, giving 4.7 radians per second. Every point on a rotating body has the same angular speed, but the linear speed of a point increases with the distance of the point from the axis of rotation, r. The linear speed at a point on the rotating body can be calculated by the angular speed times the distance of the point from the axis of rotation. So if a wind turbine's blades are 2 meters long, it rotates at 30 RPM, the angular speed of the blades is 30 times 2 pi divided by 60, which equals pi, or 3.14 radians per second. The linear speed of a bat at the centre of the turbine is 0 meters per second, as the distance from the axis of rotation is 0. Whereas the linear speed of a bat at the tip of the 2 meter blade is pi times 2, which is 6.28 meters per second. So far, we've been talking about angular speed, but what about angular velocity, where velocity is a vector, and vectors have both magnitude, or size, and direction? Linear velocity has a direction as a tangent to the circle at any point. So if you let go while rotating, this is the direction you would fly off in. The direction of angular velocity is not so obvious, and is defined using a right-hand rule, where you take your right hand, curl your fingers in the direction the object is rotating in, and your thumb will point in the direction of the angular velocity. We can then rewrite the relationship between linear velocity, angular velocity, and displacement from the axis of rotation as a vector cross product, where v equals omega cross r. And finally, what kind of bats can do somersaults? Acrobats! Thank you for watching.